So now I am going for the first colligative property. First colligative property is RLVP, relative lowering of the vapor pressure. And just I will write only 2 points, only 2 points or 3 points I will write. And whatever the points I am writing, these the points already 14 days back or fortnight back, I have informed you, I have taught you these topics. So in this, I will write point number one. Relative lowering of the vapor pressure is equal to mole fraction of the solute it is there. Mole fraction of the solute means number of moles of solute divided by number of moles of solute plus number of moles of the solvent it is there. Yesterday I have given to you that colligative properties are for dilute solutions and for dilute solutions. For dilute solutions, number of the solute is very less in comparison to number of moles of solvent. If number of moles of solute is very less in comparison to number of moles of solvent, so whatever this term it is there, this term in the denominator becomes negligible in comparison to the number of moles of a solvent, and then it becomes P naught minus P by P naught. Mole fraction of the solute is equal to number of moles of solute divided by number of moles of solvent. Keeping this in the mind, that is the reason why fortnight back this formula I have given to you. Number of moles of solute means weight divided by gram molecular mass of solute. Weight of the solute, small w, molecular mass of the solute, small m, divided by number of moles of solvent. So here, molecular mass of the solvent, capital M, capital W is the weight of the solvent, and therefore, long back, this formula I have taught you in relative lowering of the vapor pressure, isn't it? Now coming for the point number two. Point number two, RLVP, as I am applying the formula, this is our RLVP and this is our molecular mass of the solute it is there. So from this, it's very clear that RLVP is inversely proportional to molecular mass of solute. RLVP is inversely proportional to molecular mass of solute. And now I'll give here third point. Third point also taught you earlier. RLVP is independent of temperature. RLVP is independent of temperature. These 3 points, fortnight back, I have taught you. Again, just I have repeated so that you can again revise or recalculate. It is molecular mass of solute. Any doubt in this one?
No, sir.
Shall I rub this one?
Yes, sir.
Now I'll go for the point number fourth. Point number fourth is not there in syllabus. Is not there in NEET syllabus. Not at all there in NEET syllabus. But if you remember, some of you have asked me, open your book in objective 2. In objective 2, some of you have asked me question number 59. Check properly. In objective 2, some of you asked me question 59. And there I told you, I will tell you, I'll teach you afterward. I'll teach you afterward. So question number 59th concept or point number 4th here, it is not there in the syllabus. Not there in the syllabus. But as one question is given in the Akash book, therefore to solve that question, I'll teach you that concept. So this I am rubbing it. First you understand that concept. After understanding, then we will go on solving our question number 59. I'll go for point number 4. Right. Right. Vapor pressure of solution, comma, vapor pressure of solvent, comma, lowering of vapor pressure, and relative lowering of vapor pressure, and relative lowering of vapor pressure, is a calculated experimentally, is a calculated experimentally, by Oswald and Walker method. Is a calculated experimentally by Ostwald and Walker method. So now I am giving you brief information regarding Ostwald and Walker method, which is not there in the syllabus, just to solve question, that one question from the Akash book. This concept I am teaching you. So Ostwald and Walker method is helping us to calculate vapor pressure of a solution, vapor pressure of a solvent, lowering of vapor pressure, and the RLVP. Now this part I am rubbing it. First, you observe the diagram, whatever I am drawing on the blackboard, then you draw. First, you observe diagram, then you draw. So now let us go for the Ostwald and Walker method understanding part. So first you observe the diagram, then you go on. Whatever these three are there, these are pre-weighed solution bulbs. So in these three we are having solution, it is there. In these three we are having solutions are there. Whatever these three are there, and all the six are having same volume, it is there. All the six it is there, and having same size, it is there. And these three are pre-weighed solvent bulbs. So in the first three we are having solution. In the second three we are having the what? Solvent, it is there. And this is the way I am going for solvent for demarcation, so that confusion should not be there. So dot I am putting for the solvent, and dash I am going for this one. And from here we are passing, dry air. From here passing dry air. This is a covered. And here we are having clip, it is there. Here we are having clip. Clip is not allowing this to enter here. Clip is not allowing this vapor to enter here. When we will remove the clip, then vapor from this can enter in this. And now here we are having U tubes are there. U tubes are there. We are having U tubes are there. And this is nothing but pre-weighed U tubes consisting of anhydrous calcium chloride, or concentrated sulfuric acid, anhydrous calcium chloride, or concentrated sulfuric acid, or P4O10, this pre-weighed U tube consisting of anhydrous calcium chloride or concentrated sulfuric acid or P4O10, whatever these three are there from your GOC organic chemistry or from your general chemistry of your 5th A, 6th A, 7th A, you might be knowing these are very famous dehydrating agent. These three are very, very famous dehydrating agent. Observe properly. 6 bulbs are there. Out of 6 bulbs, 3 are consisting of the solution, 3 are consisting of the solvent. U tubes are there. U tubes are consisting of dehydrating agent. Not all three, anyone. Maybe anhydrous calcium chloride, maybe concentrated sulfuric acid, maybe P4O10, whichsoever is available in the lab that we can keep as in water, desiccant or the dehydrating agent. And here from this, we are passing the dry air clip. What is the job of the clip? Clip is just behaving like a valve. Clip is not allowing this vapor to enter here, and therefore clip is inserted. Once we are removing the clip, then vapor from here, they can move this side. Draw this diagram roughly. And this I have mentioned, pre-weighed solution bulb, pre-weighed solvent bulb, pre-weighed U tubes. And once copying is done, let me know.
Done.
Oh, very good.
1 minute, sir.
I'm not rubbing, but I definitely will wait. Once copying over, let me know. Anhydrous calcium chloride or concentrated sulfuric acid or P4O10, they are a dehydrating agent. What is dehydrating agent? Which removes water or moisture. Is called dehydrating agent.
Done. Completed, sir.
Good. All of you done?
Yes, sir.
Okay.
Done.
Now this I'll rub it. Diagram I won't rub. Only this part I rub. So clearly I have mentioned pre-weighed. What is the meaning of pre-weighed?
Before experiment weight.
Yes.
The weight of the bulb is known.
Before the experiment only, we are having a very clear information What is the weight of these three? What is the weight of these three? What is the weight of these three? And what is the weight of these two? It is there. That is the meaning of pre-weight. Means before passing the dry air, we are having the idea. Let us go on understanding. Here, these are the solvents. So definitely on the solvent here, accumulation of the vapor will be there. And this is the accumulation of the vapor. This is solution. These three are the solvent, and here accumulation of the vapor. Here accumulation of the vapor. Accumulation of the vapor. Now tell me, in these three and in these three, accumulation of vapor is same or different?
Different.
Different.
Where it is more?
Solute.
Solvent.
Solvent.
It is more. Diagram is very clear. In the solvent, it is more. Why solvent it is more? Because in solvent, surface is not blocked. In the solution, surface is blocked.
Because
When
of
surface is blocked, less evaporation. Less evaporation, less is the vapor. Less is the vapor, less is the vapor pressure. It is there. Now we are passing a dry air. Let us assume this is the dry air. This is the dry air. It is there. Now dry air is going here. Dry air is going in the water, our solution bulb. And when dry air is going in the solution bulb, this is a moisture. This is a moisture. It is a moisture. It is there. So can I say dry air will take a moisture?
yes, sir.
So dry air. Once dry means it will take a moisture. So dry air it is there. This dry air is taking a moisture. This is a moisture. This is a moisture. It is a moisture. It is a moisture. And this is dry air. One example, only one dry air particle I am taking for understanding. When dry air you are passing, not billions, trillions of the dry air particles will be there. Not billions, trillions of the particles will be there. But just I am taking one particle for the what understanding. And this is loaded by whom? Loaded by water vapor. This is nothing. This is an air. This is an air. And this is loaded by whom? Let us go for in this way. For understanding, it is loaded by the water vapor or moisture. Loaded by water vapor and the moisture. So earlier here we are having some moisture, was there? Now earlier this was the condition. This is a dry air and now this is a moisture. It is there. After some time we are having this condition. After some time we are having this condition. Tell me, this condition and this condition both are same or different?
Different.
What difference is there?
Yes.
Second one, we are having lesser water vapor. It is there. Water vapor. This is more water vapor. This is a lesser water vapor. It is there. Why? Because some of the water vapor is taken by the dry air. When some of the water vapor is taken by the dry air, whatever the vapor amount it is there, vapor amount is not remaining same. Check, vapor amount is what? Decreasing. When vapor amount is decreasing, whatever the pre-weight you have taken the bulb, the pre-weight bulb mass is remaining same. Mass is increasing or mass is decreasing?
Mass is decreasing.
Mass is decreasing. And now here I will write. Here I will write loss in weight or loss in weight or loss of weight. Loss of weight in solution bulb. Loss of weight in solution bulb is proportional to, keep it as it is. That's all. Now I am removing the clip. So when I am removing the clip, whatever this air particle it is there, air particle is going here. So this was the condition. Now this air particle is entering here. When this air particle is entering here, tell me what happens to this air particle? This air particle will remain as it is. This air particle will remain as it is. Or this air particle will become in this way, means whatever the water molecules, whatever the water vapor molecules it has taken, it will shed them, SHED, shed them, or it will be further loaded by water vapor molecules. Tell me
Further
what happened.
loaded by water.
Further loaded by water vapor.
That's correct. It will be further loaded by water molecules. Why? Because here
There's
vapor,
more moisture.
More.
yes, vapor pressure is high. More vapor it is there. When more vapor it is there, it will be loaded, further loaded, and therefore that's correct. It is not becoming this one, not becoming this one, further loaded. So when it is a further loaded, in this case also, mass is remaining same, mass is decreasing, mass is increasing.
Mass is increasing.
Mass is decreasing, because if here there is a decrease in the mass, it is there. Why here increase in the mass will be there? Whatever the bulb it is there, in these three bulb also there is a decrease in the mass, it is there. So therefore here it will be loss of weight in solvent bulb. Loss of the weight in solvent bulb is directly proportional. Now this is coming here. When this is coming here, when it is coming here, outside it is going in this way. The dry air particle it is there. This is the way it is going outside. This is the way it is going outside means, can I say whatever this moisture it is there, this moisture is taken by YouTube, can I say?
Yes, sir.
Yes, sir.
Moisture, here it is lost. Moisture is lost, therefore loss in mass. Moisture is lost, therefore loss in mass. Here YouTube is gaining the moisture, and therefore here I will write total loss of weight. Total loss of weight in solution bulb and solvent bulb, or gain in weight or gain of weight in U-tubes. So total loss is nothing but gain in the U-tubes is proportional to. So we are having three conditions are there: loss in the weight of solution bulb, loss of the weight in the solvent bulb, and gain in the weight of the U-tubes it is there. Whatever here loss of the weight in the solution bulb it is there, it is directly proportional to P. Why directly proportional to P? Because whatever here their saturation it is there, or whatever here water vapors are loaded, this water vapor loading is nothing but directly proportional to vapor pressure of the solution, and P is nothing but vapor pressure of the solution it is there coming for this. In this case, loss of weight in the solvent bulb is P naught minus P. Why in this case P? Why in this case P naught minus P? Because in this case, further saturation is occurring. Already it is here loading, it is there. Further loading is occurring. How much further loading is occurring? How much this is greater than this one? How much vapor pressure of this is greater than this much? That much further loading is occurring. So how much is the greater? We'll get information only by difference, and therefore in this case I am going for P naught minus P. Clearly here I am saying here we are having total loss it is there, or total gain it is there, means P. This is nothing but total loss. This is nothing but total loss or total gain. So from this, it's very clear that it is proportional to P naught. So you are getting three things. Loss in the solution bulb is equal to P. Loss in the solvent bulb is equal to P naught minus P. Total loss in the solution bulb and the solvent bulb, or total gain in the U-tube, is nothing but our P naught it is there. So by this, as half an hour back I have mentioned, by this you can calculate vapor pressure of solution. By this you can calculate vapor pressure of a solvent. By this, you can calculate lowering of the vapor pressure, or this divided by this is nothing but relative lowering of the vapor pressure. Copy this 3. And this 3 things you have to remember now for solving the question.
Done, sir.
Good. Once you have done all of you open question 59. All of you open question 59. And first, I will write what they have given in question 59. This I am not rubbing for your convenience. In question number 59, they have given loss in mass of solution bulb is how much equal to? This they have given?
Yes, sir. Yes, sir.
Can I say this is nothing but equal to P?
Yes, sir.
Then they have given what they have given? Whereas in the pure water bulb means solvent. And then here they have given loss in mass of solvent bulb. Solvent bulb is pure water. This they have given 0.08 grams. So 0.08 grams means, can I say it is nothing but P naught?
P naught minus.
Yes.
Yes, it is nothing but P naught. Now let us go for our question. Let us go for our question.
Sir, it'll be P naught minus P.
That's correct. It is P naught minus P. This is P naught minus P. It is there. Loss in the mass of solvent bulb. Now let us go on applying our thing. So can I say from 1 and 2? From 1 and 2. From 1 and 2. Clearly here they have given the value P naught minus P is 0.08. Correct? Yes or no?
Yes, sir.
Yes.
Clearly here they have given P value is 1.92. So this is this 1.92, 0.08. So from this, can I say P naught is equal to
2.
Can I say 2?
Yes, sir.
Yes.
So from this we got P naught. We are having P naught minus P, it is there. We are having P, we got P naught. No, sir, why you are calculating P naught to solve our question? Because our question is
P naught equals to mole
P naught minus P by P naught is equal to mole fraction of the solute. Tell me in this, what is the question asked?
mole
Mole
fraction of
fraction.
Yes, mole fraction they have asked. So when they have asked mole fraction, so therefore P naught value is nothing but it is 2. Whatever the P value it is there, it is 1.92. And this is nothing but 2, it is there. Can I say?
Yes.
So can I say this is nothing but 0.08 divided by 2? So can I say 0.04?
Yes, sir.
Yes, sir.
So you see, for solving one question, I have given you roughly more than half an hour Ostwald and Walker method, which is not there in syllabus. Which is not there in the syllabus, but in local examination questions are coming. Local examination questions are coming. That is the reason why this risk I have taken. So Ostwald and Walker method is having multiple purpose. By that we can calculate vapor pressure of the solution. vapor pressure of the solvent, lowering of the vapor pressure, and our desired relative lowering of the vapor pressure. And our desired relative lowering of the vapor pressure. Done?
Yes.
Once copied, let me know.
It's done.
Good. So first colligative property, that is relative lowering of the vapor pressure, has been completed in detail. And now I'll go for the second colligative property, which I have mentioned yesterday, that is elevation of boiling point. And now I'm going for the second colligative property, elevation of boiling point. Now coming for the second colligative property, Roman number 1. Yesterday, I have given you explanation of why the word is called elevation of the boiling point. This point I have given to you. Just go on writing basic points. After basic points, I'll go for the formula. Basic point. The temperature at which vapor pressure of liquid is equal to atmospheric pressure is called boiling point of that liquid. Boiling point of that liquid. Point number 2. So whatever 3 or 4 points now I'm giving to you, all the points I have taught you earlier. Vapor pressure is inversely proportional to boiling point. It is second point. Third point. Vapor pressure of a solvent is higher. Vapor pressure of solvent is higher than vapor pressure of solute. Vapor pressure of a solvent is higher than vapor pressure of solute. Full stop. Therefore, boiling point of solvent in bracket T0. Therefore, boiling point of solvent in the bracket T0 is lesser than boiling point of solution in the bracket T. Boiling point of solution in the bracket T.
Boiling point of solute, no, sir.
Boiling point is less than boiling point of solution T.
Repeat again. So can you repeat the third point, please?
Where is the question of repetition? 10 times I have repeated. 10 times
Sir,
I
is
have
it
repeated.
vapor pressure of solution or solute, sir?
Yes, sir.
Where you were there. Where you were there. Where you were there. Now coming for third point. Now coming, this is, theater is not going on better. Theater is not going on. Wah wah, wah wah. Already 10 times I am repeating. If I'll go on repeating 20 times, I look fool. I look fool only. Then when the syllabus will complete? Coming for point number third, I have given to you. Vapor pressure of the solvent is greater than vapor pressure of the solution. Vapor pressure of the solvent is greater than the vapor pressure of the solution. Therefore, boiling vapor pressure of the solvent is greater than vapor pressure of the solution. Therefore, boiling point of the solvent is less than the boiling point of the solution. By God, if I would have been written, I would have been saved time.
We got it, sir.
Vapor pressure of a solvent is greater than vapor pressure of solution. Therefore, boiling point of a solvent is less than boiling point of a solution. Next time, better write on the blackboard. It will save a lot of time. Point number fourth. Point number fourth is based upon point number third. Therefore, elevation of boiling point. Therefore, elevation of boiling point is equal to elevation of boiling point, delta TB is equal to TB minus TB naught. What is TB? TB is a boiling point of a solution. Deliberately, I'm writing B. B indicates boiling point of a solution. What is TB naught? TB naught is nothing but a boiling point of the what pure solvent it is there. And I have mentioned that T is greater than T naught. When T is greater than T naught, so this difference is nothing but delta TB, and delta TB is nothing but called as our elevation in the boiling point it is there. And these are the points already have taught you 1 week, 10 days back. These are not the new point it is there. Anyone doubt in these 4 points?
No, sir.
Now I'll go for the point number 5th. Point number 5th is the graph I'll give to you. This graph already I have given to you in the topic where I have taught you Clapeyron equation. So this is nothing but our vapor pressure. It is there increasing. And here I'll go for the water temperature. It is there. And whatever this dotted line I am writing, dotted line is nothing but 1 atm. 1 atm is nothing but our atmospheric pressure. Why I am going for atmospheric pressure? Because the temperature at which vapor pressure is equal to the atmospheric pressure, that temperature is called as a boiling point. Now, We know very well when the vapor pressure and the temperature graph it is there, we are having exponential curve it is there. So two exponential curve I am drawing. This is one exponential curve. It is another exponential curve. In the examination, let us assume this is number one. This is assume number two. Tell me out of this number one and the number two, which one is a for a solution, which one is for a solvent?
Second one is for a solution and the first one is for
Which one is for a solution, which one is for a solvent?
First one is solvent, sir. Second one solution.
Yes, first one is a solvent. Don't forget the basic point. Solvent will have high vapor pressure, and yes, this vapor pressure is high. This is solution, this is solvent. Solvent will have high vapor pressure, and this is a solution. Solution is having lesser vapor pressure. This is one hint. Second hint is a boiling point. This is the temperature. This is the temperature at which vapor pressure of the solvent is equal to the atmospheric pressure. So this temperature is called as a T naught B. Coming for this temperature. This is the temperature at which vapor pressure of the solution is equal to the atmospheric pressure, and this is nothing but TB. And we know very well that boiling point of the solution is greater than that of the boiling point of the what solvent it is there. And whatever this difference it is there, this difference in the boiling point is called as a delta TB. So how in the examination? Yes, in the examination, local and the final, they are giving question based upon the graph. They'll give this type of the graph, and here I have written, here they will say X, and question will be asked, X is equal to what? Or what is X? X is nothing but our elevation in the boiling point, it is there, and therefore here I will write, this is nothing but our delta TB or elevation in boiling point. Once it is copied, let me know.
completed, sir.
Good.
Done, sir.
Good, beta. Good. Very good. Very good, beta. Now, the next is in derivation part. It is there, and derivation part probably I can't complete in that 6 or 7 minutes, and therefore I won't go for. So, what will I advise you? Still, you are having time of 7 to 8 minutes. It is there that you should not waste. Test portion is from where solubility na. Again read, because rather than reading on Saturday night, if daily you are reading half an hour for test portion, daily means daily, full marks. Full means full marks. If from my track 22 questions are coming, all 22 correct. All 22 correct for you. Start. That 7 or 8 minutes you are not losing. You are just going on solving the questions, going on reading the theory part, maybe from the book or maybe from the NCERT book, or maybe whatever I have given to you, that one, or your wish, going on solving the problems. Or in the Akash book, they have given some solved questions, correct? In the Akash book, if you observe, this is your Akash book, it is there. And in that, if you observe, they might have given you some solved questions. They might have given you some solved questions.
20 page. No?
Yes, some solved questions. Page number 20, correct? That solved questions you are trying from question number 22 to question number 29. Question number 22 to question number 29. Try that questions. And after trying for 4 or 5 minutes, if any doubt it is there, definitely ask. Start.
What's for dinner? Also, roll credits.
So single question from a cash book, you should not be in the position to leave.
51
Cash book
seconds
and
of motherfucking-
NCRT now only you have to take it, eat it, digest it, but it should not come outside. It should not come outside.
logos.
It's said that the West was.
Narration.
This is the legend of the Ghost Rider.
It's what's for dinner. Also, roll credits. Whatever this is.
He outran the devil himself.
Well, that doesn't even sound possible. Also, that's pretty easy when the devil doesn't run. Also, the devil's lone mode of transportation is running, apparently.
The thing about legends is sometimes they're true.
And sometimes they're not. Any other gems of wisdom for me before we get started? Carnivals.
Son, everything you do in life.
They're not. Any other gems of wisdom for me before we get started? Carnivals.
Son, everything you do in life, every choice you make has a consequence.
And with that great powerful responsibility comes great, f it.
When you do things without thinking, you ain't making the choice is making you.
Whatever that shit means. Marlboro somehow agreed to this product placement that placed their product in direct proximity to a man coughing to death from their product. There you go, kid, because he can never find more cigarettes at the carnival. Johnny and Roxanne's love is addicted to trees. Forever.
My dad's sending me to live with my mom.
But I figure when I turn 24 tomorrow, I'll officially be on my own.
So what are we gonna do, Johnny?
Impregnate her already!
Tomorrow, noon. We'll meet here.
Yeah, no sense in just leaving right now, because that'll give fate enough time to put some kind of stupid obstacle in our way. Movie hits the f***ing expositional jackpot with this shot right here. Oh, random pieces of paper in the trash? Better give that probably important document a look. Barton very neatly threw this letter into the wastebasket, instead of just crumbling it up like any sorry sack of shit smoker who doesn't give a f*** about cancer would do.
Where you going?
Nowhere, Dad.
He could be easy riding his way to Bangtown with Roxanne tomorrow, but he just had to be curious about trash, didn't he?
Far out.
You know, for all the 60-year-olds in the audience who enjoyed Easy Rider.
Johnny Blaze.
Discount Johnny Storm.
Just wanted to tell you how much I enjoyed watching you ride.
At a lot o'clock, and well after closing, and not in a creepy manner at all.
Perhaps you'd ride for me one day.
Apparently Satan needs ghost riders for speedy bounty hunting. He had a horse rider, and now he's recruiting a motorcycle rider. But why not choose a helicopter pilot? Why does the devil's soul-collecting ability have the limitation of earthly speed anyway? And why is he recruiting his future rider roughly 20 years before he actually needs him? How did the lightning outside cause a shadow like this? This is clearly an inside light shadow, but whatever. Devil's devil is devil.
What if I could help your dad? Would you be willing to make a deal?
Name your price.
Sure, strange dude I've never seen before in my life at the traveling carnival. I'll follow you anywhere.
I'll take your soul.
Yes, the creepy guy who showed up out of nowhere and started talking about your cancer, Dad.
Anyone in that questions from 22 to 29? Any doubt? If doubt is there, say yes. If doubt is not there, say no. What is the meaning of silence? Yes, that is the good answer. Either you say yes or you say no. Simply maintaining a silence is what? So tomorrow I'll calculate the leftover part of the elevation of the boiling point, and depression of the freezing point is exactly same. Just on the place of the word elevation, I'll use the word depression. Formula is the same, understanding is same. Two or three points are differential points are there. On that differential points, I'll give a stress and I'll make you that you put star mark there. Let us meet tomorrow at same time. See you. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, Beta. Thank you.
Thank